Hello, everyone, and welcome. Today, we will discuss one of the most important combustion and explosion principles in fire engineering and process safety: surface area to volume ratio. This principle explains why some materials burn slowly while the same material in small particles, dust, vapor, or a thin layer can burn extremely fast and sometimes even explode violently. And honestly, this concept is everywhere in the process industries, from refineries to chemical plants to other process facilities and to power handling systems. Understanding this principle can help prevent catastrophic fire and explosion. The rule is actually very simple. When the exposed surface area of a fuel increases, more fuel contact oxygen, heat transfer becomes faster, vaporization increase, and combustion speed increase dramatically. In simple words, the more exposed the fuel surface we have, the faster and more violent the fire can become. Let's imagine two situations. Example A, one large solid block. Imagine one large block of material. Because it is one large piece, the exposed surface area is relatively small. Oxygen can only contact the outer surface. Heat penetrates more slowly. Combustion remains relatively slow, so the fire develops gradually. But in other scenarios, same material broken into small pieces. Now imagine taking that same material and divide it into many tiny particles. Suddenly, total surface area becomes enormous. Oxygen contact increase, heat spreads rapidly, combustion accelerates dramatically. This is why powders, dust, vapor, and aerosol are often far more dangerous than solid material. And this is one of the core principles behind industrial explosion. A very important principle to remember is this: more exposed the fuel surface plus oxygen contact equals faster combustion. This concept is fundamental in fire engineering, dust explosion analysis, explosion prevention, and process safety management. Now let's move to one of the most dangerous industrial examples: dust explosion. This is extremely important in refineries and industrial plants. Example includes sulfur dust, flour dust, methyl dust, and others. Fine dust particles have extremely large surface area compared to their volume. That means excellent oxygen contact, rapid ignition, very fast flame propagation, and the result can be devastating. A suspended dust can create a powerful explosion. Let's take methyl as an example. A solid steel bar usually burns very slow, but the same methyl as fine powder, it may burn extremely rapidly, produce fireballs, create violent explosion. Why? Because the exposed surface area becomes enormous. This is why dust accumulation inside facility is a major process safety concern. Another refinery example is hydrocarbon spill. A thin oil spill on the ground burns much faster than the same amount of oil stored inside the drum. Why? Because the oil has more exposed surface area, more vapor generation, better oxygen contact, and this increases combustion speed significantly. Now let's discuss vapor cloud explosion. Gasoline vapor mixed with air has extremely high contact with oxygen molecules. This creates very rapid flame propagation, sudden pressure rise, explosion potential. This is one of the reasons why vapor releases in process industry are extremely dangerous. One very important lesson in process safety is this: Small particles are often more dangerous than large material because they create more surface area, faster heat transfer, faster vaporization, faster combustion, higher explosion severity. And this principle must always be considered during hazard analysis, dust handling, chemical transfer, hydrocarbon operation, and facility design. So, how do industries control the risk? Typically, protection measures include dust collection systems, good housekeeping, preventing dust accumulation, venting system, inert gas system, ignition source control, grounding and bonding, proper ventilation, limiting turbulence during power transfer, and these controls are essential for reducing explosion risk. Let's finish with one simple fire engineering rule. The greater the exposed surface area of fuel, the faster and more violent combustion can become. This is a simple principle, but it explains some of the most destructive industrial fire and explosion in history. Understanding this concept can save facility, equipment, and lives. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share the channel with other process safety professionals. Stay safe.